States of matter. Section 1. 4 states of matter. Key concept. Each state of matter has a characteristic way in which its particles interact.
As you read this section, keep in mind what you will learn. All matter is made of particles that are in constant motion. Each state of matter depends on the motion of its particles. In solids, particles can only vibrate. In liquids, particles can collide with and move past one another. In gases, particles are free to move independently, colliding frequently. In plasmas, particles move independently and are broken apart. Why it matters. Understanding the states of matter will help you understand natural processes in the world around you. In this section, you will learn the following new vocabulary. States of matter: solid, liquid, gas, plasma.
You get home from school and decide to make yourself a snack. There are some leftovers in the refrigerator from your dinner last night. So, you heat some up in the microwave oven. As the food heats up, you begin to smell the food. You're also thirsty, so you put some ice in a glass, clink, and fill the glass with water. You take a big gulp. Ah! Matter. Moving particles. The scene described above has examples of the 3 most familiar states of matter. Those states of matter are solid, liquid, and gas. The states of matter are the physical forms of a substance. The states of matter depend on the motion of particles. Matter is made up of very tiny particles called atoms and molecules. Atoms and molecules are in constant motion and are always bumping into each other. The motion of particles is different for each state of matter. The way that the particles interact with each other also helps determine the state of the matter. Figure 1 describes 3 states of matter: solid, liquid, and gas in terms of the motion and attraction of the particles. Solids. Imagine dropping a marble into a bottle. Would anything happen to the shape or size of the marble? Would the shape or size of the marble change if you put it in a larger bottle? A marble keeps its original shape and volume no matter where it is placed because it is a solid. A solid is the state of matter that has a definite shape and volume. The particles of a substance in a solid state are very close together. They have a strong attraction between them. The particles in a solid move, but they do not move fast enough to overcome the attraction between them. Therefore, each particle is closely locked in position and can only vibrate in place. Liquids. What do you think would change about orange juice if you poured the juice from a can into a glass? Would the volume of juice be different? Would the taste of the juice change? The only thing that would change when the juice is poured into the glass is the shape of the juice. The shape changes because juice is a liquid. Liquid is the state of matter that has a definite volume but takes the shape of its container. The particles in liquids move fast enough to overcome some of the attractions between them. The particles collide with and slide past each other, but the particles remain close together. Because the juice is a liquid, its volume stays the same, whether you pour the juice into a large container or into a small one. Figure 2 shows the same volume of liquid in 2 different containers. Gases. Would you believe that 1 tank of helium can fill several hundred balloons? How is this possible? After all, the tank is only as big as about 5 filled balloons. Helium is a gas. Gas is a state of matter that has no definite volume or shape. The particles of a gas have little attraction between them. The particles move about freely and collide randomly with each other. Because gas particles move about freely, the amount of empty space between them can change. Look at figure 3. The particles of helium in the balloons are farther apart than the particles of helium in the tank. As helium particles fill the balloon, they spread apart. The greater amount of empty space between the particles makes the volume of the gas larger. Plasmas. The sun and other stars are made of the most common state of matter in the universe, called plasma. Plasma is the state of matter that does not have a definite shape or volume and whose particles have broken apart. More than 99% of the matter in the universe is plasma. Plasmas have some properties that are quite different from the properties of gases. Plasmas conduct electric current, but gases do not. Electric and magnetic fields affect plasmas, but do not affect gases. In fact, strong magnetic fields are sometimes used to contain very hot plasmas that would destroy a solid container. Here on Earth, natural plasmas are found in lightning and fire. Plasma sometimes forms during storms on Earth by the electrical energy in lightning, as shown in Figure 4. Artificial plasmas, found in fluorescent lights and plasma balls, are created by passing electric charges through gas.